The increased use of electronic modules to control automotive operation has brought along with it systems that allow those modules to communicate. Over the years, MasterTech has covered those systems, including the C2D bus and the PCI bus communication networks. With the introduction of the 2004 Durango, there will soon be another communication network you need to be familiar with. One that is made up of different buses which have been combined in one system. Welcome to this month's MasterTech Controller Area Network, or CAN buses. To familiarize you with this new communications network, we'll start off with an overview of the CAN buses, followed by a look at their operation. Then we'll discuss CAN bus diagnosis, including the resources and tools you'll need to be familiar with. We'll end the program with some sample problems that illustrate how this network is different from ones you've worked on in the past. One important thing to keep in mind when dealing with a CAN bus system is that its features can change from one application to another. The 2004 Durango will be the first Chrysler Group vehicle to use CAN, followed by the 2005 Chrysler 300 models and the Dodge Magnum. Eventually, all Chrysler Group vehicles will use CAN. In this program, the focus will be on the system as it occurs on the Durango. However, we will point out a few of the features of the system on the cars. No matter what the application, there are a number of reasons for using a CAN bus system. For one thing, using the CAN bus system allows Daimler Chrysler to meet an EPA and CARB mandate. This mandate requires a common communications protocol for emission-related components and systems. However, there are other good reasons for using CAN. One is its speed. The slower CAN bus is still 8 times faster than PCI, and the faster CAN buses are about 50 times faster. Using CAN bus is also cheaper. It's a non-proprietary system with readily available components. One of the CAN bus system's general features that makes it distinctly different from the PCI is the wiring. CAN buses use 2 wires, like the C2D bus that preceded PCI. And like the wires in the C2D, CAN bus wires are twisted. In the case of CAN, there are about 40 twists per meter. The wires are also similar to C2D in that one is designated minus and the other plus. Because the wires can be in one of 3 buses, the specific bus name is also used in the wiring designations. You may have noticed the reference to CAN buses in our discussion. That's because the CAN system actually uses different buses for different groups of control modules. On the Durango, these buses are known as CAN B, CAN C, and CAN C Diagnostic. The CAN B bus operates at 83 kilobits per second and provides communication for a variety of components. The CAN C bus operates at 500 kilobits per second and is used for systems requiring high speed, such as powertrain and ABS. The CAN C Diagnostic bus also operates at 500 kilobits per second. It's used to provide a link between the StarScan diagnostic tool and the controller that coordinates the operation of the CAN buses. This controller is referred to as the CAN bus central gateway. On Durango, the controllers for the central gateway and the front control module are combined in one unit. As a result, this unit is referred to as the front control central gateway module. In other applications, the central gateway may be associated with another module. The central gateway controller on Durango has a number of jobs to do. For one thing, it separates the 3 buses so that they can operate at different speeds. Because of the separation that the central gateway provides, parts of the network can continue to operate even when other parts may not be operating. In addition to separation, the central gateway processes messages from modules and relays those messages that need to travel to another bus or to the StarScan scan tool. It also monitors the network to keep track of which modules are communicating. Any network diagnostic trouble codes it records can be retrieved with the StarScan. Speaking of trouble codes, with the arrival of the CAN buses, you're going to see some significant differences in DTC designations. Like the P codes you are probably familiar with, other codes now use a letter prefix to indicate the area they affect. In addition to P codes for powertrain, modules now use U codes for network communication. C is the letter prefix for chassis codes, and B is used for body codes. Because of the use of these letter prefixes, DTCs on CAN bus vehicles now follow SAE standards. And with the change to letter prefixes, some diagnostic trouble code descriptions used on CAN bus vehicles will not be the same as on other vehicles. As with other bus networks, when more than one module is broadcasting on one of the CAN buses, arbitration is used to decide which message has priority. This month's reference book contains an explanation of how it's done. Design features like arbitration are not something you're going to notice in CAN bus operation. One big difference you will notice is the way in which modules and their inputs and outputs interact. A lot more of that interaction depends on the bus network now. That's because the inputs and outputs needed for any particular system can be hardwired to modules based on proximity or convenience. This is different from systems in which inputs and outputs are always wired to the modules which use them. For example, the fan relay on Durango is wired to the front control module, not the PCM. When the PCM decides the fan relay needs to operate, it sends a message to the front control module, which activates the relay. On the input side, the AC pressure sensor is also wired to the FCM. The FCM then sends AC pressure info to the PCM via the bus. This bus design is referred to as distributed electrical architecture, and it's common to all CAN bus systems. What may not be common is the way the bus system is set up on specific vehicles. Next, we're going to look at the operation of the CAN buses on Durango in more detail, including what happens if a malfunction prevents normal operation. In this segment, we're going to examine the individual buses that make up the Durango CAN bus system. Let's start with the bus which connects the greatest number of modules, CAN B. On Durango, the CAN B bus links a large number of electronic modules which control the body and safety systems shown here. See this month's reference book for a complete list of the modules on the CAN B bus. CAN B bus operation occurs whenever modules need to communicate on the bus. This normally occurs with the key in the on position, but it can also occur when the ignition switch is in the off position and the key is removed, such as when someone uses the remote keyless entry transmitter to unlock the vehicle. In that case, the Sentry Key remote entry module communicates the request to the cab compartment node. Such a request will cause the bus to become active if it had previously been in something called the sleep mode. To prevent battery drain when the ignition is off and bus operation is not needed, the CAN B bus initiates the sleep mode once all of the modules on the bus become inactive. It's important to keep this sleep mode in mind when troubleshooting ignition off draw concerns, since without it, the module activity can drain the battery. When the bus is asleep, bus minus is at 12 volts and bus plus is around 0. When the CAN B bus is awake, bus plus and bus minus voltages switch between approximately 5 volts and 0 volts to produce signals. You may be familiar with termination resistance from studying other bus systems. CAN B has termination resistance as well. This termination resistance is inserted between bus plus and ground and is only present when the bus is active. For that reason, you cannot measure the resistance of the CAN-B bus as you would other bus systems you may have worked on in the past. Earlier, we briefly mentioned that when a malfunction occurs, the central gateway is responsible for communicating the trouble. This can take different forms. For one thing, modules relay trouble codes of all kinds to the star scan through the central gateway. If these trouble codes concern the bus, they will be preceded by the letter U. The central gateway also monitors the bus for malfunctions and will store trouble codes when it detects them. When it comes to malfunctions, the CAN-B bus is more fault tolerant than the other CAN buses. In fact, if a condition only affects one wire, or if both wires are shorted together, the bus can continue to operate in a single wire mode. In this mode, the bus may not perform as well as with both wires functioning normally. If both wires are open, bus messages may also get through depending on the location of the break and the modules involved. More serious conditions, such as both wires shorted to power or ground, can cause the bus to stop communicating. The symptoms that result from bus malfunctions depend on where the malfunction occurs and how severe it is. If the malfunction shuts down bus communication, there will be obvious and widespread symptoms, including a number of systems that don't work, improper indications or lighting in displays, and in certain cases, warning lamp illumination. Malfunctions that are less severe may prevent individual systems from operating or may cause them to respond slowly. Once again, you need to remember that inputs and outputs are distributed throughout the electrical system. As a result, a malfunction in one part of the bus network may prevent an input from reaching a system in another part, causing symptoms that do not necessarily reflect where the malfunction is occurring. For that reason, it's crucial to depend on star scan for information concerning bus malfunctions, and not just symptoms. At this point, let's turn our attention to the next part of the Durango bus network, CAN-C. On Durango, the CAN-C bus supports fewer modules than CAN-B, but at 500 kilobits per second, it's about 6 times faster. The Next Generation Controller, or NGC, is on the CAN-C bus. You are probably aware that this controller places the powertrain controller and transmission controller in one box. Also on the CAN-C bus is the controller for ABS and stability control. And the central gateway is part of the CAN-C bus. Unlike the CAN-B bus, CAN-C is only active when the key is on. When the bus is active, the central gateway needs to receive responses at regular intervals from CAN-C modules, or it will report them as not responding. The voltage pulses used by the CAN-C bus to create bits for messages are different than those used by CAN-B. For one bit, both bus plus and bus minus are at around 2.5 volts. For the other bit, bus plus is switched to around 3.5 volts, and bus minus is switched to around 1.5 volts. Voltage levels fall to 0 when the bus is off. There is no sleep mode. Termination resistance is also handled differently on the CAN-C bus. Resistance is inserted between bus plus and bus minus instead of between the bus wiring and ground. Two modules have a resistance of around 120 ohms apiece, and the others have a resistance of several thousand ohms each. Also, unlike CAN-B, the resistance is present with the key off, and you can check it with an ohmmeter. Earlier we discussed how CAN-B can continue to operate when a malfunction occurs. CAN-C is not tolerant of malfunctions. Any wiring or module malfunctions related to the bus will cause it to cease operation. The central gateway is responsible for monitoring CAN-C operation, and any bus failure it records can be retrieved with StarScan via the CAN-C Diagnostic bus. The central gateway is also responsible for relaying any trouble codes reported by modules on the CAN-C bus. As you might expect, symptoms associated with CAN-C failure tend to occur in systems which have modules on the CAN-C bus. So you could see the temperature gauge indicating full hot, temp and oil pressure warning lamps on, and the red brake warning lamp on. If the bus stopped communicating with the key in the on position, the Prindle display will show the gear the transmission was in when the failure occurred. With a bus failure at key on, all of the segments are illuminated. The same caution holds true here as with the CAN-B bus, however. Because inputs and outputs are distributed throughout the electrical system, a problem with a component wired to a module on the CAN-B bus can affect module operation on CAN-C. Your best bet really is to trust the information you receive via the StarScan scan tool. Much of what we've said about the operation of the CAN-C bus is also true of CAN-C Diagnostic. They both run at the same speed and use the same voltage levels to create bits for messages. Both are also not tolerant of malfunctions. Of course, the modules are different on CAN-C Diagnostic. Actually, in this case, you can refer to the items on the bus as nodes, since in addition to the central gateway, the StarScan is a participant on CAN-C Diagnostic when it's connected to a vehicle. Another difference is the termination resistance, which is around 60 ohms at the central gateway. Just as with CAN-C, the resistance is present with the key off, and you can check it with an ohm meter. On Durango, one thing the CAN-B, CAN-C, and CAN-C Diagnostic buses have in common is that the central gateway controller is part of all of them. Future CAN bus applications will not necessarily incorporate the central gateway in the box for the front control module, but they will use a gateway module of some sort. In addition, you may see modules which are not gateway modules connected to more than one bus. The CAN bus design has been around for a while and is a proven performer. In fact, Mercedes-Benz first used it in 1992 as a vehicle communications system. It has also been used in a limited way for communications between modules on Cummins diesel applications since 1998. However, if a malfunction occurs, you'll need to be familiar with troubleshooting resources and tools. That's the subject of the next part of this program. If you watched last month's Master Tech about StarScan, you're already familiar with one of the tools used to troubleshoot the CAN buses. StarScan is designed to provide you with detailed information that can help you quickly isolate bus concerns. Network View on the StarScan homepage is particularly useful. Durango's 3 CAN buses are represented in this view, and network components that may have a problem are highlighted in red. Selecting a highlighted area leads to more detail and an indication of the problem. For example, here we select the CAN-B bus, which has been highlighted in red. This brings up a list of stored and active diagnostic trouble codes for that bus. The fact that a part of Network View is highlighted in red does not necessarily mean there is a bus problem. For example, here we select the CAN-C group of modules, which has been highlighted in red. Notice here that all of the modules are communicating on the bus. However, the PCM has recorded a trouble code with a P prefix. The ECU view on StarScan does not represent the CAN bus system in a diagram. Instead, it lists all of the networked control modules regardless of which bus they are on. However, this view will show you which modules are communicating on each bus and how many trouble codes have been set. In an effort to simplify diagnosis, StarScan also provides a view that allows you to troubleshoot the vehicle electronics according to system. System View lets you see all of the inputs and outputs used by a system, no matter what module they come from. Besides the star scan to troubleshoot the CAN buses, you'll also need a digital multimeter, or DMM. The DMM is used to check for shorts, opens, and resistance in bus components. As with previous bus systems, it's important to use a methodical approach which covers all of the bases when troubleshooting a CAN bus system. That should be easier to do with the new format for service and diagnostic information. This new format combines service manual type information, wiring diagrams, and diagnostic procedures in one location. In addition, the service information now uses a storyboard approach to explain repair procedures. Wiring diagrams have also been simplified and refined for easier use, as have diagnostic procedures, which now have art that illustrates the step being performed. Earlier, we discussed some of the symptoms you might find in cases of partial or complete lack of communication on the buses. Because of the way components are integrated into a CAN bus system, these symptoms may or may not point to a cause. That's why it's important to use the star scan to determine the status of bus components. And when you have retrieved diagnostic information, such as diagnostic trouble codes, it's important to use the published procedures to investigate the cause. For example, the fact that a module is not responding does not necessarily mean anything is wrong with the module itself. The problem could be in the module power supply or ground, or the module connector or wiring. In addition to the diagnostic procedures, the wiring diagrams contain critical information that will help you locate bus components during testing. At this point, let's look at a couple of situations that illustrate what it's like to work on a vehicle equipped with a CAN bus system. In the first case, a Durango has been brought in with the mill lamp on and a complaint that the vehicle tends to run hot at low speeds under load. A check with the star scan and network view shows that there is at least one trouble code in the group of modules on CAN C and in those on CAN B. Selecting the modules on CAN B reveals a code related to the fan relay recorded by the front control module. The reason it's in this module as well as in the PCM is because, as mentioned earlier, the front control module actually controls the fan relay in response to bus messages from the PCM. The next step is to use the diagnostic procedures associated with the code to find the cause. Here's another situation that shows what you might run into on a CAN bus vehicle. In this case, a Durango was brought in because the air conditioning failed to operate. While confirming the complaint, the technician noticed that the compressor clutch did not engage when AC was selected. A check of network view with the scan tool revealed that the groups of modules associated with CAN C and CAN B were highlighted in red. Selecting the modules on CAN B revealed a code related to the AC pressure sensor in the front control central gateway module. Once again, the next step was to use the diagnostic procedures to isolate the cause of the code. You can see how helpful the star scan can be when it comes to locating the potential cause of a diagnostic trouble code. The scan tool can also help you confirm that the repair has been successful. For one thing, codes that are no longer present will change from an active to a stored status. For another, the network view will not have any red highlights once codes have been cleared and the systems are operating normally. Last month's MasterTech can help you learn more about using the star scan tool, and future MasterTech programs will take a closer look at vehicles using CAN bus systems. In October, we'll be covering the 2004 Durango new model service highlights. And in the first quarter of 2004, we'll be looking at highlights of the all-new Chrysler 300 models and the Dodge Magnum. You can also sign up for the Vehicle Communications course, which explores all of the bus communications systems used on Chrysler Group vehicles over the years. In the future, you'll be seeing a lot more CAN bus systems. Even though some of these systems may not be exactly like Durango's, the knowledge you gain from this program should serve as a basis for understanding these other applications. Be sure to join us again next month when we'll be covering some developments in powertrains.